In this video, we're going to look at the second half of systems of equations. In the first video, we talked about how to solve via graphing, and now we're going to look at the other two methods, substitution and elimination method. So let's recap. What is a system of equations? A system of equations is simply two or more equations grouped together as one unit, such as the ones here. Remember that the solution is any ordered pair that makes both equations true. So in the picture, that is the ordered pair where the two lines intersect. A system can either be consistent and dependent, or inconsistent. Now, how can we find solutions? Three main methods are graphing, substitution, and elimination. In the previous video, we talked about graphing. In this video, we're going to look at the other two methods, elimination and substitution. Substitution. Substitution is when we substitute one variable with an equivalent expression. So we did this with the linear applications. We're going to do the same thing we did here. Suppose if y equals x minus 2, and if I have 3x plus 4y equals 10, then this equation becomes 3 times 4, or 3x plus 4 times the quantity of x minus 2, which equals 10. What we did is we substituted the value, that expression, in for y. This is why it's called substitution. We are literally substituting one variable with an expression of the terms of the other. What this does is it allows us to solve a single equation with one linear variable. We did this in the linear application homework, but now we're using it. We can write equations as two different equations and then combine one into the other. So let's do a practice problem. Let's suppose we want to solve by substitution this system. Now, because we have two equations where neither equation is solved for one variable, we can choose which one we want to solve for. We can solve for either x or for y in one of the equations to then replace into the other equation. I'm going to go ahead and I will take the second equation and I'm going to solve for y. So I have 2x minus 4y equals 8. If I solve for y, I'm going to have negative 4y must equal 8 minus 2x, and then I divide both sides by negative 4, excuse me, and then I'm going to get negative 2 plus 1/2 x. I'm going to now take this expression and replace it in for y of the first equation. So this is my substitution. 3x plus 5 times the quantity of negative 2 plus 1/2 x must equal 15. Now I have one equation with one unknown value, and I can now solve for that unknown value. 3x minus 10 plus 5/2 x must be 15. 3 plus 5/2, which is the same thing as 2.5. So essentially I have 5.5x is going to be the same thing as 25 if I add 10 to both sides of the equation. Now I want to divide both sides by 5.5. I missed my decimal point. There we go. Now this does give me a simplified fraction of 50 over 11. Now, remember that a system has to have an ordered pair as a solution. Since we found a value for x, this tells me that we have one unique solution. But we only found half of that solution. Remember that a solution must be in terms of x and y. So we need to find the y. How can we find the y? We will back substitute into our substitution. So y is going to equal negative 2 times 1/2, or plus 1/2 times 50 over 11. So y is going to equal negative 2 plus 25 over 11. Y is going to equal, so we have negative 2 plus 25 divided by 11. We're going to get 3 over 11. That means my final solution is the ordered pair 50 over 11 and 3 over 11. Because of the solution of 50 11ths to 3 11ths, what we have is a consistent and independent system. Please note that you can still solve this with graphing. We would still find that the solution, where the two lines intersect, would be this ordered pair. Elimination method. Elimination method is when we eliminate one variable through addition. You can also be seeing this as calling elimination method. What we do here is we manipulate the equations so that we are able to add the equations together, where when we do, one of the coefficients of the variables becomes 0. Because if the coefficient of a variable is 0, then the variable disappears, because 0 times anything is 0. So for example, if we had 3x plus 6y equals 12 and 5x minus 6y is 30, if we were to combine the equations together by adding the like terms on each side, we would end up eliminating the variable of y. In other words, this y right here, these would cancel out, leaving us with just x, and therefore we can solve the equation for x. Let's try a problem. If I want to solve by elimination, I'm going to figure out which variable I want to eliminate. Now, there are many different ways you can start, and there's many different ways you can choose. You always have to decide what variable you want to eliminate, and then from there we can determine what we have to multiply the equations by. We could either figure out how to add, or we want to add these two together to give us a 0, or we want to add these two to give us a 0. Now, since the y has a positive and a negative coefficient, I'm going to eliminate y. But if I add them as is, positive 5 and a negative 4 does not equal 0. I need to make it so that when I do add them together, I get 0. So I think about what is the common multiple between 5 and negative 4. Well, we know that 5 times 4 is 20. So if I can make the coefficients of y be positive and negative 20 respectively, if I add those together, I get rid of my y. So I'm going to multiply each equation by a number. Remember, by the multiplication property of equality, I can multiply any non-zero number to an equation. As long as I multiply to each term, it has an equivalent equation. So I'm going to take my first equation, and I'm going to multiply both sides by 4. Why 4? Because I want to make sure that my 5y becomes 20y. Why do I want it to be 20y? Because I want to make this one negative 20y. So this will give me the new equation of 12x plus 20y equals 60. For the second equation, I'm going to multiply this equation by 5. Why 5? Because I want to be able to make the coefficient of my y to be negative 20. And why do I want it to be negative 20? It's because my coefficient of my previous one, I changed to 20. So this will give me 10x minus 20y must equal 40. Now if I add the equations together as is, I'll be able to eliminate the y, which is what I wanted to do. This leaves me with 22x equals 100. Therefore, I can solve for x and I get 100 over 22. Now, if you recognize, this is the same system as what we solved with substitution, which means I should get the same answer for x, which I do. Consequently then, y is going to be that 3 over 11. But we can find the y by replacing it into, or we can find the y by replacing my x into one of the equations. It doesn't matter which one. And then I'll use that to find the y. Whichever way we find our y, we now have our solution. Our solution is the ordered pair, 5 over 11 and 3/11. In class, we'll look at some problems where the system is consistent but dependent, or if it's inconsistent, and we'll see how we write the solutions. We'll also practice more of elimination and substitution method in class.